sometimes with ionic compounds, you also get waters incorporated actually as part of the crystal structure. So it's really important that you actually include these in the name as well. And there is always going to be a prefix that tells you how many, they're called waters of crystallization, how many units of waters of crystallization there are per the empirical formula unit. And the waters themselves, the substances that contain these waters are called hydrates or hydrated ionic compounds. So the fun thing is these waters, it's not like you can just heat them up to 100 degrees Celsius and they'll disappear. Usually you would actually have to supply a lot more heat than that because they are actually chemically part of the crystal structure. So a little later on when you're working out molar masses and stuff, or like how much of this strontium hydroxide octahydrate do I have to actually weigh out, please do remember to include all waters of crystallization in your molecular mass that you're calculating, formula mass, because they are actually in there, so they weigh something, they contribute to the mass. Okay, so don't forget that. Okay, so we're going to go from the name to the compound. So this just goes to show, right, you should be able to write unequivocally what the formula for the ionic compound is from the name. Another thing is with these hydrates, they come after, I guess, like, it's not really a period, it's like more like when you do like the dot product or something, like it is a big circle dot thing between, in this case, the strontium hydroxide and the hydrates. So without any further ado, strontium hydroxide would be Sr, and then there will be 2 hydroxides, because remember, strontium is 2+, and the hydroxide ion is -1. And then we would have this dot thing. I wonder if I can draw it nicely, like here. I'm going to just get a circle. This will do. So dot, and then I'm going to put my hydrates in. In this case, it's an octahydrate. The prefix octa means 8. So there is going to be 8 H2Os associated with that structure. Would help if I actually typed an 8, huh? So there we go. Strontium hydroxide octahydrate. Let's do another one. All right, so write the systemic name of blah. Okay, so let's work on the first part first. So that is manganese. Give me my thingamy here. Manganese sulfate. And how many waters are there? There are 5. The prefix for 5 is penta. Here it is, right? So it'll be manganese sulfate pentahydrate. Okay, one more then. Let's see what we got. Chemical formula of barium hydroxide octahydrate. Well, it's going to be the same, but barium there instead of strontium. Here we go. FePO4.4H2O. So let's just make sure we've got iron. It's going to be iron 3+ and phosphate, PO4 3-, right? So that'll be iron. Oh, it's a transition metal. So you've got to say that it's iron 3, phosphate. And then if I could spell phosphate, that'd be great. How many waters are there? There are 4. So 4 is going to be tetrahydrate. So iron 3 phosphate tetrahydrate. And notice you really must include the charge on that iron. That is iron 3, not iron 2 or whatever, because otherwise that will be marked as incorrect. See if we've got another one where you write the name. Yeah, writing the name. Excellent. Okay, so what's the systemic name of this guy? No, I wanted to do another one we did the formula. So that'd be iron 3 nitrate nonahydrate. Okay. I want one where we write the formula. Lithium iodide trihydrate, iron 2 sulfate hexahydrate. Okay, apparently it's not going to give me another one of those where we had to work backwards to the formula. Magnesium carbonate trihydrate. Okay, so you don't need the Roman numerals when it's not a transition metal. Here we go. Iron 3 nitrate nonahydrate. Okay, so iron 3, Fe3+, and then nitrate is NO3-, so we know it's going to be FeNO3, and there's going to be 3 of them, and then the nonahydrate is going to be 9 waters, and then I'm going to have my little dot thing in between. So that would be the iron 3 nitrate nonahydrate. There you go. You can do it too.